So we're going to start off the year with limits, and the three big ideas in calculus are first, limits. This is the basic of everything in calculus. So we're going to spend about a month on that. That's the first topic, but it's not the longest. The second part is derivative, which will take us all the way to the end of first semester. And then the last topic is integral, which will be the last thing we talk about until the AP test. So 3 topics, and they all connect to each other. So if any time you get stuck on anything, you gotta ask questions, because it's not like your previous math classes where if you don't remember this, it's okay, kind of. Everything is integrated with each other. So if you don't know something, you got to find out, or else you won't be able to do any of the other stuff that comes later. So yeah, anytime you have questions, please ask. Okay, so the first topic is about limit, and we're going to kind of review this a little bit with things you have learned in pre-calc, things you have learned in Algebra 2. So limit definition, or this limit notation, if you remember, the way you read it is limit as x goes close to a number, y, which is f of x, goes to some number. So that's how you write limit, and again, this is what it means here. If f of x becomes arbitrarily close to a single number L as x approaches let's put a, from either side, then the limit of f of x as x approaches a is L. So the kind of key thing is either side, but I'll kind of explain that later. Let's just talk about what limit is. Okay, let's see how much you remember from pre-calc. So let's look at this first picture. Limit as x goes to -1. So when x is going to -1, what do you think the limit is? So when x is going to -1 on this graph. When x is going to -1 on this graph, well, you see when x is -1, there are some problems. There's a point here, there's a hole here. So the question is, when x is going to -1, okay, and the key is from both sides. So if you kind of remember the chapter in pre-calc, the last chapter when we talked about calculus, you probably would be able to do this. But if you don't remember, this is kind of a review. When x goes to -1, the key is from both sides. From both sides of the graph. Where does y go to? Where does y, or f of x, go to? F of x goes to -1. When both sides of the graph is going to -1 on x. Okay, so the graph is going to -1, the graph is going to -1. Then where is y going to? Y is going to this spot, -1. Then you ask, what does this mean then? Well, limit by definition is, if you kind of look back here, arbitrarily gets close to, and x approaches. It never says when x is equal to. It just says when x approaches. So when x is going to this x value from both sides of the graph, so then that's kind of the key. From both sides of the graph, it has to be on the graph, like moving with the actual curve, not a single point that is standing somewhere out in space. So those are not the numbers we're talking about. So when you're following the graph from both sides to get to this x value, where is y going to end up at? Not whether y exists, because of arbitrarily close. So y does not exist, that's true, because there's a hole, but it is going close to -1. And we just ignore this point because it's not even part of the graph. Okay, let's look at the second one. Same thing here. When x is going to -1, where is y going to? So limit as x goes to -1, what is f of x? Well, this one is a little bit easier because there is no hole. So then if you follow the graph towards x equals -1, y is at -1. Third option, you have this graph that looks like this. There is a hole with no extra dot somewhere else. So same question. When the limit as x goes to -1, f of x is equal to what? When x is going to -1, y is also going to -1. Okay, so the key idea here is limit as x goes to a number, we're asking ourselves, if I follow this graph from both sides of this x value, what y value do I get? Okay, not what is it equal to. Yeah, sometimes you could have an equal to, you do have a solid dot, but it's not a requirement. It could be an open circle like this, and you would still say the limit is this number. Okay, I think I've said too much about it. All right, let's look at another example. So let's say that you're given this function and you don't know how this function looks like, but you do have this table of values that tells you what's going on as you get close to some number. The question is, the limit as x goes to 1, what is f of x equal to? So the question is, when you're going to 1 from both sides of x, where is y going to? Okay, so if you look at this table, x equals 1 is this one. They're asking you what the limit is. That means where is y going to? So then my question for you first is it necessary for y to exist? Is it necessary for y to exist at x equals 1? When I say exist, I mean that there is an actual point. So is it necessary for there to be an actual point? No, it is not. Because we're talking about a limit, which means just both sides, when both sides of x equals 1 is going to 1, x equals 1, where is y going to? So y does not have to exist, it just has to be getting close to. So then let's look at both sides of x. These are numbers that's close to 1 from both sides of it, right? This is like smaller than 1, smaller than 1. This is bigger than 1, bigger than 1, bigger than 1. And then so as we get closer to x equals 1, what y value does it look like it's converging to? Well, it's pretty obvious. It's converging to 3. So then this is 3. Will there be a point at 3? We don't know, but it doesn't matter. It's going to 3 on both sides. All right, then let us look at some more examples with different things. So the first thing we looked at was how to find limits using a graph. The second thing we looked at was how to find a limit using tables of values. Now we're going to look at how to find limits if you're given functions. So given this piecewise function, let's kind of review piecewise function. F of x, that means y, equals to this number, 1, when x is not equal to 2. And this y, f of x, equals to 0 when x is 2. So I'm going to kind of just draw it out for you for now, and then I'm going to show you how to do it, just kind of thinking about it. Okay, so when x is not equal to 2, y is 1. So, y is going to be 1 when x is not 2. When x is 2, okay, so when x is not 2, y is 1. So basically x is going to be, y is always going to be 1 except at 2. So except at 2 means that there is a hole. When x is 2, y is 0. So that's how the graph looks like. And so the question says, find the limit as x of f as x approaches 2. So essentially what it's asking is limit as x goes to 2. What is f of x? Now that you have the graphical form, it's very easy to see this is equal to 1. Now, what happens if you don't have this graph? Well, first of all, translate this question into a limit form, right? That way you know kind of mathematically what it's asking for. And then the next thing is it's asking you what's going on at 2. What's going on at 2? Well, if you look at this function here, it tells you at 2 it's this. However, not at 2 is this. We're actually looking for the not at 2 because not at 2 actually means that the graph is it's continuous. Like there is actually a curve going on every single x. At 2 means that it could actually be just a single point kind of out in the space somewhere by itself. So that is not part of the curve. So when this question says, what's going on at 2 for the limit, we actually want to look for the not 2, not equal to 2. So kind of a little trick there to find limit. Okay, so that's kind of how you do it with piecewise function. What I've showed you now is kind of a intuitive way of looking at it, but on the AP test you cannot do it this way. There is a way to prove the limit, and I'll show you that later on in this chapter. All right, let's give yourself a practice here. So go ahead and pause the video and try this. Find the limit using this piecewise graph. All right, so hopefully you got 2 and 4 right. If you got 1 and 3 wrong, that's okay. We're going to talk about it really quickly. All right, so 2 and 4 are pretty simple. That's kind of what we talked about. When x is going to 1, it is continuous. You do have a point there, so it's just 1. When you're going to x equals 4, both sides are going to 4, and y is also going to 4, so then the limit is 4. 1 and 3 are a little bit tricky because I haven't talked about it. Okay, so remember limit, I said the most important thing is saying about limit is it's x going to that number from both sides. From both sides is the key. So when you're going to 0 from the left-hand side and you're going to 0 from the right-hand side, well, what y values do you get? When you go from the left-hand side, you get 0 for y. When you go from the right-hand side, you get 2 for y. When the numbers are not the same, it does not exist. Both sides have to go to the same y value for a limit to exist. So since they're going to different values, we would say this does not exist. So does not exist, or DNE. So DNE is a perfectly fine answer, or you write does not exist. Try not to write something like this, or try to not write something like no solution. When we're in calculus, we want to use very exact words. So please don't make up your own words for what you think the answer is, because your definition may not be the correct definition. It could be interpreted differently, and we get into a whole mess of things like someone interpreted wrong, and anyways, so please just write the definition I give you. Okay, so number 3 is the same thing. When x is going to 2, left-hand side is going to -2, right-hand side is going to 0. They're not going to the same y value, so that does not exist. All right, so now let's talk about really quickly the situations when limits do not exist. So first, we kind of talked about that first situation when the left-hand and right-hand side go to different number. Okay, so in this example, limit as x goes to 0, f of x, both sides are not going to the same number, so this does not exist. Okay, so that's the first example. The second example is called unbounded. So this kind of same thing. Limit as x goes to 0, what does f of x go to? Left-hand side of the function as x goes to 0 goes straight up. Straight up means infinity. It's not actually going to go to a number because it's just shooting straight up. The right-hand side also goes straight up. So both sides go to, kind of like infinity that as infinitely large number. We could write infinity, but infinity is not a limit, so we say does not exist, like this. Okay, so unbounded situation means that the limit is going straight up or straight down. It could also be straight down. So one side goes straight up, one side goes straight down. So one goes to infinity, one goes to negative infinity. That is still saying that it does not exist. The third situation is that you have an oscillating behavior. So the question is, limit as x goes to 0, where does y go to? Well, as you get closer and closer to 0, it keeps going up and down between 1 and negative 1 in this case. Since you're oscillating, you cannot stop at a value, then you cannot compare the two sides. They're always going to be different. There might be a case where they're kind of the same, but then they keep going up and down, and we cannot say that they're the same. Like they're both oscillating at the same rate. No, we cannot say that. Therefore, we say this is also does not exist. So 3 kinds of situations. First, both sides just obviously go to different numbers. Second, shooting up to infinity, shooting down to negative infinity, or one goes to infinity, one goes to negative infinity. Either way, infinity is no limit or it does not exist. The third kind is when you have oscillation. So it oscillates even more as you get closer to 0. Then that does not exist. Now, if you look at the situation with sine graph is not a situation of oscillating because at 0, they both go to 0 from both sides. That's different from this one where it's just oscillating even more and more as you get closer. So that's not the same. So try to be able to tell the difference between the two. All right. So let's have you guys try these. Find the limit. You can either use the decimals or find a table or something. Find the limit of the following. All right, let's look at the answers. So I'm not sure if you use decimals to find the limit, or you could have graphed it on your graphing calculator and looked at it, or you can use the graphing calculator to find a table. And to find a table, what you would do is first you input your graph in y equals, and then you would go to the second button, and then go to graph. And then when you do that, it's actually picking the table option from the top of that. And then you're going to see this chart that looks like this, x and then y1, whatever you put in y1, and then y2 and so on. And then if you have yours set at every integer, it's going to start at whatever number you want it to start at. And then it's going to give you some values. I don't think the first is 0. But anyways, it would give you that. And then you can try to see what's happening when you're getting close to a x value. Okay, so let's look at the answers. So for number 1, the answer is 0.25. Number 2 is 0.02. Number 3, this one's a little bit tricky, 1. Number 4 does not exist. And then number 5 is 0.0001.